Welcome everybody for today class on nuclear accident analysis and disaster management. Our today class is on, as usual, some scenario of the nuclear accident and what are the safety parameters and what are the analysis procedure, followed by nuclear power plant uh, different level of accident scenario. In the last class, I explained about the difference in depth, or which is composed of 5 levels. Okay, for the defense in depth, it is composed of 5 levels. You must have to remember these 5 levels. The first level is called the prevention of incident occurring. That means before occurring any incident, what are the prevention need to be taken? You must have to know. So second level, it will be again the prevention of progressing the way or the system that from incident to accident. That means it is going to more what you call the negative impact of this one. It initially it was incident, but now it is going to be accident. So the progress, the scenario of the progress, the trend of the progress, you must have to prevent. And the level 3 is the most important, the prevention of radioactive material released into the environment. If anything happened in accident, then if there is a leakage and radioactive material is going outside to the environment, you have to take the prevention measure or activities. So level 4, 3 is important. Level 4, of course, if there is any severe accident, you have to take the management procedure, policy, and so on. And finally, after nuclear accident or anything happened, that is called the post-accident, you have to take the preparedness, emergency preparedness, or the response preparedness. So I already mentioned about how to achieve the safety level for each defense level, means all the 5 level, how you will achieve, that is given. Uh, for the anticipated operational occurrence, that is AO in normal, the level that is called the level 2, prevention of accident or progressive accident from incident, that is anticipated operational occurrence AO. So event categories, it is under level 2 and before level 3. So abnormal change you will notice in the nuclear reactor, especially in the control room or the control system. The shift engineer or the shift supervisor, they will notice that there is some abnormality in the reactivity or in the power distribution or the turbine load in the reactor core. So abnormal change in heat generation or removal in the core, abnormal change in the reactor coolant pressure, or also the outer level height. So that type of abnormality, if it is found, then means there is something happened. That means it is going to be the level 2 from level 1. That means from incident to accident. So event categories for a DBA, design basis accident, loss of reactor coolant or considerable change in core cooling or loss of coolant accident. That means the reactor coolant, there will be some loss. The reactor coolant, the temperature will be rise. So it is called the loss of coolant accident. You know that one. Abnormal reactivity insertion, that I'll discuss later on again. However, inserted reaction means it can be the positive insertion or it can be negative insertion. That means the nuclear chain reaction, the fission will be in, continue and the temperature will be high. Or rapid change in the reactor power, it is fluctuating. So that means it is going to your accident level 2. Abnormal release of radioactive materials, that is of course, an abnormal change in pressure, atmosphere, etc. in the reactor containment. That's why there will be some design basis accident. So what you have to take the action, that is the basic action, basic procedure about the prevention of the level 2. I think you know, to stop the nuclear reaction, you cannot shut down suddenly the nuclear power plant reaction. Then you have to cool the reactor core. You have to give some time to cool the reactor core, then to confine the radioactive materials. So these are the fundamental safety actions we need to take that on. However, uh, according to the International Nuclear Security Event Scale, we call it INES, International Nuclear Security Event Scale. So previously, the level was until 5, but up, I told you previous last class that after Fukushima accident in 2011, and also the Chernobyl accident in 1986, this level 5 is two more level is introduced under International Nuclear Security Scale. First one, definitely it is 0 is not measure, it is below the scale event. The first one is the 1 that is called the anomaly. That means something is happened, but sometimes it is correct, sometimes it is wrong. But level 2, it is coming some incident, means abnormality is increasing, especially emergency core cooling system and so on. You must have to be ready to prevent that incident. Now, serious incident. Serious incident means it is going to be the accident. So abnormality is very high. In that case, you have to take the preparation, also the emergency core cooling system. Now, level 4 accident without significant offsite risk. It is accident, inside there is accident, maybe the power trip or the turbine trip is happened, but not outside there is not much risk. That is called the coolant accident. It was happened in 1999, but it was not affect to the environment. No radioactivity released. It is just inside. So that is level 4. Now, level 5 accident with offsite risk means there will be radioactivity release, like a TMI nuclear power plant accident in 1979. So outside there is some risk. Number 6 is serious accident. So it is going to be very high level of accident. Means the radioactivity release, the containment is the reactor core meltdown, and then the reactor containment, what you call, the burst, that neutron burst, that is called the neutron burst. Okay, and because of that, the environment affected. So yeah, the radioactivity was released very high. You see here, and uh, finally the major accident that is called under the scale 7. It happened in Fukushima accident as well as Chernobyl accident. Lot of the damage happened, lot of death happened. So that's why uh, these after TMI, after NP, Chernobyl accident and Fukushima accident, previous 5 level of scale, it is increased until 7. So that is the we call the international nuclear security scale. So incident and accident, the difference between incident and accidents. Incident is means in operable normal operation. That means in the during the operation time there is something happened, but it can be mitigated. So no severe risk on the outside of the reactor containment or the radioactivity affect to the environment. But accident definitely when radioactivity goes to the outside to the affect to the environment. So that time it is called the accident in nuclear language. Okay. Now we go back to the concept of defense in depth that already mentioned earlier, but here is summary here. Okay, defense in depth. I told you the first one is the prevention of incident occurring, that is level 2, and level 1 and level 2 is progressing from incident to accident. So how you prevent the incident occurring? Definitely, your design must be correct. Your interlock, the system should be proper design. Your quality of high quality of education for the operator must be there. Then definitely quality assurance. You have to there should be check. Checkbook means in any control room there is a shift engineer. Inside the shift engineer there will be logbook. Logbook means the morning session, how much the temperature, what was the pressure, and what was the water level. So this is called the quality assurance. Need to check back. And after 2 hours operation or after 3 hours operation, how much the temperature, how much the pressure, that must be written in the logbook. And like this way, it is quality assurance can be checked. So this and also there will be all the latest technologies that self-regulating characteristic means automatically the reactor the chain reaction will be shut down. That is under self-regulating characteristic. So if you have like this type of prevention capacity, then it is possible to prevent the incident occurring. Next level, level 2 prevention of progressing. I told you that is from incident to accident. That means abnormality is increasing. So you have to be prepared about the reactor protection system. Like you have to shut down the chain reaction so that your reactor power will be goes down. And also the decay heat renewal, it can be down happened when any reactor core meltdown, then there will be decay heat renewal system. So you must have to be the cool down. You have to be proper moderator. You have to be proper coolant so that your heat can be removed. Heat can be decayed. And also there will be engineered some safety system like as most important emergency core cooling system. If anything happened, then from you can use the emergency core cooling system. So this is under engineered safety system. And next level is the prevention of if accident happen, then there will be some criteria or some protection system so that you can prevent your radioactivity release to the environment. So that is called the containment building. Containment system, you must have to be properly designed so that inside the reactor core, the meltdown, but reactor containment in such a way it is designed that it can sustain to release the to avoid the release of the radioactivity. So this is under engineered safety system. So especially the containment building. Okay. So the basic concept is taking safety measures step by step. There will be 3 points. The first point, not to, in order not to occur incident. That means incident not be happen, then you have to take the some preparation, some measurement, some design factor. So this is all are under defense in depth. Like introduction of diversity and redundancy system, I already mentioned previously. It is most important before implementing or before operating any system, any plant or anything. So if you have sufficient diversity and redundancy of the component of the system, then it is possible to avoid the incident. Again, striving through the managing of quality assurance, I already mentioned you, skilled up of the operators, the periodically inspection, monitoring of the operators, and that training, sufficient training. That's is important for the first point. That means not to occur incident. So it is possible to avoid the incident. Second point, in order not to progress from incident to accident. That means it was in level 2. How you can prevent that one? You have to prevent by the prevention of occurrence of fuel failure by reliable shutdown and cool down. Means if something happened, abnormality, if it is high from incident to accident in the reactor core, you have to shut down the chain reaction. You have to cool down the reactor, the fuel and the other reactor containment. So that is possible. That is the way to avoid the accident in level 2. Third point, accident already happened. So your purpose, your target to be that not to release the radioactive materials. That is most important. How your containment building, containment system, or the emergency core cooling system, the concrete shielding material, concrete shielding wall should be properly designed so that it can prevent the uh, radioactivity. Another important part is the self-regulating characteristic. Self-regulating characteristic is basically in second point. In second point, that means if it is uh, accident happen, is going to be accident happen, then how you shut down the reactor chain reaction and cool down. This is the part of the second point. So that we can do by using the self-regulating characteristic of the your boiling water reactor or pressurized water reactor. The first one, let's say happened, unexpected disturbance is coming. Some abnormality is coming in the nuclear fission or nuclear reaction. Nuclear fission is increasing. That means you have to check, you have to see on the monitor, the control system room that your nuclear fission is increasing. that means there is possibility to reactor power is increasing. And then in your monitor, you will see the reactor power is going up. If reactor power is going up, what will happen? Your fuel temperature will be increased. If fuel temperature is increased, then surrounding moderator or coolant will be heated up, or the temperature of the coolant will be rising. If coolant temperature is rise, then what will happen? There will be some void. There will be some the smaller bubble will be produced inside the coolant, and if the bubble is happened or created, this bubble will reduce the density of the coolant. If the density of the coolant is reduced, then your the nuclear reaction will be decreased. Chain reaction will be decreased because Newton there will not be possible to keep the reaction continue. So there will be some possibility to reduce the chain reaction. That is called the negative reactivity. Negative reactivity, it will happen due to the void effect and the density effect. And these are called the Doppler effect. These are called the Doppler effect. Doppler effect means the higher probability of absorption. That means when unexpected disturbance and increase in nuclear fission will be happen, so something will be happen so that the neutron will be absorbed by using the Doppler effect. How? Because of this way. Number one, when nuclear fission is going up, reactor power definitely will go up. More energy will be produced. So more power will be produced. And when more power will be produced, definitely the fuel temperature will be increased because more heat is generated inside the fuel. And I think you already know about the reactor thermal hydraulics that I already taught you, that when more heat Q prime or Q triple prime heat generation will be very high, then your temperature inside will be very high, especially inside the middle of the center point of the reactor fuel. So if the fuel temperature is high, then your temperature will be transferred to the coolant will be high. If the temperature of the coolant is very high, there is possibility to create some bubble. That is called the void effect. And because of the bubble or void effect of the coolant, the density will be reduced. That will because of the bubble. So when density will be reduced, then it will absorb some neutron. Absorption, there will be some higher probability of absorption. It cause the Doppler effect, and it will create the negative reactivity insertion. It will create the negative reactivity insertion, means reduction of reactor power. So reduction of reactor power, the another name is uh, called negative reactivity insertion or negative reactivity feedback. This is the Doppler effect. This is the Doppler effect. It arises from the dependence of the Newton cross section on the relative velocity between the neutron and nucleus. Okay, so then already I mentioned you negative reactivity means it will absorb the neutron and decrease in the nuclear fission. If the nuclear fission decrease, then definitely reactor power or heat generation will be decreased, and in that way reactor power can be down. Again, if it is down, then fuel temperature will be lower. Fuel temperature will be lower means the reactor coolant will be also lower, and the bubble or void effect will be reduced. So again, it will be the continuing the chain reaction. So this is the way there will be self-regulating of BWR and PWR. Okay, and in that way we can prevent the nuclear burst if anything happens. So it is finally, it is a physical phenomena. If any temperature in a core rises, reactor power automatically goes down by temperature. Okay, remember, if the temperature inside the reactor core increases, reactor power will be down. But how? With the temperature effect. Because the temperature will be increased, and due to the increase of the temperature, there will be bubble or void effect, and also the density effect. All this is called the Doppler effect, and this is the physical phenomenon. So you have to remember about the Doppler effect. Doppler effect, again I repeat, I think you know, again I am repeating, Doppler effect, it is the broadened resonance or heating of a fuel. Heating of a fuel or temperature of a fuel increase. It will result a higher probability of absorption. And finally, it will create the negative reactivity insertion, means the reactor power will be reduced. And because of the reactor power reduced, your chain reaction will be reduced, or decreasing of the fission will be happen. That means fission will be decreased. And if nuclear fission decrease, definitely reactor power will be down. So this is the Doppler. Okay. Image, if you see the image of the reactivity. Reactivity expresses the degree related to nuclear fission, I already mentioned. And there are two types of reactivity, also I told you, positive reactivity and negative reactivity. The purpose of the positive reactivity to increase the fission, and negative reactivity, the purpose is to decrease the fission, or by using the control rod, or we call it self-regulating characteristic. So when the fission will be very high, then control rod will play the role. That means you insert the control rod inside, then your reactivity you can control. So this is the example of the Doppler effect for uranium fuel. I'm not going to explain this one. This is not the part of our this one. And self-regulating characteristic, already I told you. Let's say in the operation time is reduced. Fission, if it is reduced, the power will be reduced. And again, if power reduced, the temperature of the fuel will be reduced. So sorry, uh, can you see the slide? Okay. So in that way, normal operation will be happen. Okay. The density effect and void effect, I already mentioned you. It is written all the details here that I mentioned you. Because of the thermal expansion of the heated, the moderator or the water will be will decrease the density because of the void effect, because of the bubble. Okay. And in heat and water become hard to collide, and in that case, there will be less collision, and because of the distance, and there will be speed of Newton will be reduced. If it is the Newton is reduced, then definitely there will be fission or chain reaction will be reduced. Okay, self already I mentioned here. I am not going to explain in details. That one already mentioned. Now, for another, the level 1 prevention measure is called the fail-safe design. Means when you go for any design system, you have to keep in mind about the fail-safe design. That means the system function always acts in a safety design, safety mode. Even if the system malfunction occurs, like as control rod holding mechanism, you have to design in such a way the holding mechanism of the control rod will be more easy. If anything happens, then uh, control rod can be. Assalamu alaikum, sir. Sir, আমি একটা ক্লাসে আছি, একটু পরে কন্টাক্ট করি স্যার। Okay, sir. So this will be happen again. Another is called the safety valve mechanism, or that means automatically it will be open or close during the loss of driving force. So these all are under the fail-safe design. So if the loss of power happen or occurs, the control rod will be dropped immediately. So your holding mechanism should be designed in such a way that if you see any abnormality in power, that means power is going to up, definitely in that time control rod will go down from the holding mechanism, supposed to automatically or immediately. If there is some problem in the handling mechanism, that means your design is not correct. That's why it is called the fail-safe design. Your design should be properly in during the especially this type of. Again, the power breaker system or others like as called the control logic or the production logic system, automatic door, and many other things are included here. I just give the example here about the controller. Like as another thing is interlock design concept. This is another concept. There is a two door there. On one door, if it is open until other door is closed or open, it will not be closed. So that is called interlock design concept. Example I have mentioned here: door at the entrance of a building accessing in a reactor shall be doubled, and one door cannot be opened before the other door is closed. That means if you enter inside the control room or reactor control system room, then there will be two doors. One is door is entry point, another door is the exit point inside. So this door will be uh, closed when before the open the other door. That means other door, you are entering from this side and you are leaving from other side, other door. So that door will be open when this entry door is closed. So that's why it is called one door cannot be opened before the other door is closed. So in that design, in that type of design, we also can ensure the, the protection system. There are many others. So these are the concept. I'm not going in details. For securing safety of system components, interlock system for reactor shutdown by reactor protection system, emergency core cooling system, and then also blocking starting of circulation pump. You can block there, and you also the withdrawal operation of control rod, also the neutral plug signal, then some others. So these are called the interlock design concept. These are the examples that you can read later on. And the most important and most easiest one that you already know about the reliability of the safety related equipment. Reliability, how we can ensure the reliability of the safety system equipment. First, you have to select the reasonable materials which is available. You have to select the system or a structure in such a way that it must be redundant. You have to ensure the reliability by repeating performance endurance test and perfect quality control with perfect inspection such as impurity, a dimensional problem, welding problem, any defect, any crack is happened inside the pipe or inside the system and so on. So, and finally, you have to keep the sufficient design margin. That means some tolerance you have to keep in mind. Due to the temperature expansion, thermal expansion, your dimension will be changed. So you have to keep in mind in that way. So for that case, reliability, there will be three important parts. One is diversity, mentioned earlier, redundancy also mentioned earlier, and the third point is independency. So this is new. Diversity means same purpose you can fulfill by two different or more different component or system. Like as example here, you can go from your one place to another place if it is near by car or by bicycle. So this is the diversity of the component to fulfill the purpose. Similarly, redundancy. Redundancy means if you buy a car or buy any component, you must have to be alternate same type of car. So that's why it is called the redundancy or multiplicity. And last one, independency. It is a fact that more than two system or equipment do not simultaneously lose their function. Means if you have some system inside the reactor core, the two system will not uh, fall or will not break or will not lose at a time. Definitely one may be lost or may be broken, but other one should be sustained. That's called the independency. Okay. Okay. So this way we can ensure the reliability of the safety related equipment. Three but diversity, redundancy, and independency. Okay. And last part I told you that sufficient design margin. Where you can keep the margin? Definitely in fuel design, because when fuel will be heated, it there is a possibility to the expansion of the fuel. So definitely if you don't keep the margin, then that fuel there is a tendency to melt, which will create the accident. So this is example about the sufficient design margin. Similarly, core design, reactor core, you have to design in such a way so that it can have some ability to sustain the temperature. And then structural design, definitely the material properties you have to keep in mind, strain, fatigue, tensile, and also the shielding material about the absorbing the radioactivity. And finally, the seismic design. That means you have to design the reactor containment or reactor core or the vessel in such a way that the earthquake they can sustain. So this is one of the example about the safety margin in fuel design, especially for the melting point of the fuel and cladding during the loss of coolant accident. If you see here, it is the normal operation condition, and this is during the loss of coolant accident happened. So in normal operation, there is a reactor pressure vessel with the thickness of 16 centimeter. It is designed. There is a control rod. There is a fuel inside, and everything is happened normally. And the fuel temperature is usually 1740 degrees Celsius. So nothing to be happened here because it is normal operation. But when anything happened inside, that is called the loss of coolant state or loss of coolant accident. It will heat it up. Your rod fuel is going to be heated up, and because the fuel heated up, your moderator or coolant will be heated up. The temperature of the coolant will be high, and it is red color. So it will melt your containment. If it is containment, there is possibility to leakage. So if it is leakage, definitely there will be radioactivity will go out. So, like example, your fuel flat temperature is going very high. It was designed, it was 1740 degrees Celsius, but it is going to be 200, 400 or 2800 almost degrees Celsius. And the fuel cladding that is composed by zinc alloy, it is roughly 1850 degrees Celsius. So that means when you design your fuel or fuel cladding, then you have to keep in mind that this type of temperature can be happen. So your design in such a way so that it can sustain the initial study you have to do, that is less than 1 year. Then after completing this initial 1 year study, you have to go for the second study. Then after completing this initial 1 year study, you have to go for the second study. Then after completing this initial 1 year study, you have to go for the second study. Then okay, I'm going to finish this one.
The class time shares.
Finish. Okay. Uh, just this slide. So high educated training and education are important for the safety nuclear safety or safety margin. Okay. So I think thank you very much. Anybody any question please before leaving? No. Okay, everybody please write down